Hello, for this problem, we've got a cabinet with a weight of 30 pounds. It's sitting on a 15-degree angle. So this cabinet has a pair of rubber feet in the front at B and a pair of frictionless wheels in the back at A. So we've only got friction at the front, not at the back. We want to know what is the minimum value of static coefficient of friction for the rubber wheels or rubber feet at the front needed to ensure that the cabinet does not roll down the incline. All right, so with this, we're going to treat it like an equilibrium problem, and we are at the point of impending motion. And we're going to figure out what is the coefficient of friction at that point. So with our equilibrium equation, first thing we want to do is draw a free body diagram. So we're going to take our rectangle. That is our cabinet, kind of like this. It's at that 15-degree angle. And we're going to set up the x and y axes in line with the incline itself. So kind of like that. All right, so the forces acting on my cabinet, I'm going to have a gravity force in the middle. So Fg, it's going to be equal to 30 pounds. I'm going to have a normal force at the back. Again, perpendicular to surface, same thing, a normal force at the front. And then I've got a friction force that only exists at that front rubber stopper or rubber feet in the front. So FF is going to exist over here. All right, so next up is I'm going to add some dimensions and angles. So this gravity, so everything lines up with X and Y except for the gravity force now. And that gravity force is going to be 15 degrees off of the vertical, off of the y-axis. So the center of gravity is going to be 10 inches from the back and 8 inches from the front. And it's going to be 18 inches from the floor. And with that, we've got our free body diagram complete. So now that we've got that complete, we're going to go ahead and move on to our equilibrium equations. So for that, we're going to start with sum of forces in the x, and that's going to be, well, the x component of gravity, so 30 sine of 15, minus the friction force. So that's going to the right, this is going to the left. For the sum of forces in the y, I'm going to have F and A, I'm going to have F and B, and I'm going to have the y component of gravity, so 30 cosine 15. All right, and then finally, I'm going to have the sum of moments. So I'm going to take the moments about point A. Sum of moments, oops. About point A. And so for that, I'm going to have the x and y components of gravity force, and then the FNB is also going to exert that. So FNB is simple. That's going to be simply FNB times 18. And then the gravity force, so the x component of the gravity force would be clockwise moment. So that's going to be negative 30 sine of 15, and the vertical distance is 18 inches. And then I'm also going to have the y component, so minus 30 cosine 15, that's the y component of gravity, and that distance is 10 inches. All right, so that is our sum of forces in the x, sum of forces in the y, and sum of moments. So in this case, what I can do is I'll notice that there's only F and B in this piece down here. So I can basically take the moment equation and solve for F and B. So Jumping to the next page, so FNB is going to be equal to 30 times the sine of 15 times 18 plus 30 cosine of 15 times 10 divided by 18. So FNB is going to end up being equal to 23.86 pounds. All right, so that's one variable solved for. I can also, at this point, go to the x equation and say, well, friction force FF was going to be equal to 30 sine of 15. And so the friction force was going to be 7.76 pounds. And with that, I actually can figure out what my coefficient of friction is, because if we are assuming impending motion, friction force is just barely enough to hold this up, my friction force is going to be mu static times FNB. And I'm just doing FNB because friction only exists at that front piece. So rearranging this, mu static is going to be equal to FF over FNB. So if I take 7.76 divided by 23.86, I wind up with my static coefficient of friction of 0.325. This is the minimum coefficient of friction needed to prevent this cabinet from rolling down the hill. All right, and with that, that's the answer we're looking for. That's what we've got for today. So thank you for watching, and I hope to see you again.